So welcome to this class. In this short video, we are going to demonstrate how to solve a system of linear equations involving three unknowns using Gauss-Jordan elimination method. So the problem is, use Gauss-Jordan elimination method to solve the system x1 minus 2x2 plus 3x3 equals to 9, minus x1 plus 3x2 equals to minus 4, and x2x1 minus 5x2 plus 5x3 equals to 17. So if you don't remember the steps on how to solve Gauss system of linear equations by Gauss-Jordan elimination method, please watch the previous video on the steps that you need to follow. So the first step is to ensure that each equation has all the variables under consideration. So for this given problem, second equation doesn't have an x3, but we can always fix that position so that the augmented form or augmented matrix becomes 1 minus 2, 3 minus 1, 3, 0, 2 minus 5, 5, and then 9 minus 4, 17. So this is step 1, to write the system in augmented form. So step 2 is what we call row operations. And so we do it in 2 steps. First, we use row operations to transform the augmented matrix in row echelon form. And then finally, we still use row operations to transform the row echelon form into reduced row echelon form. So we have 1 minus 2, 3, and then 9, minus 1, 3, 0, minus 4, 2, minus 5, 5, and then 17. So the first step, this is 1, so row 1, we leave it to be the ratio is row 1. Row 2, we expect this position to be 0, so we'll say row 2 equals to row 1 plus 1 row 1, so row 2 plus 1 row 1. Row 3, we also expect this to be 0, so we'll say row 3 plus minus 2 row 1. If you can't do these steps at the same time, do row 2 first and then go to row 3, but you can as well do it together. So this will lead us to 1 minus 2, 3, 9. Minus 1 plus 1 is 0. 3 plus minus 2 is 1. 0 plus 3 is 3. Minus 4 plus 9 is 5. 2 plus minus 2 is 0. Minus 5 plus minus 2 times minus 2, the same as minus 5 plus 4, which is minus 1. 5 plus minus 2 times 3 is minus 6. So 5 plus minus 6 is minus 1. 17 plus minus 2 times 9. So 17 minus 18 is minus 1. That's what we have. So then now this is 1, okay? So we expect this one to be 1. So we say row 1 to be row 1, row 2 to be row 2, and then row 3, we say row 3 plus 1 row 2. So that this will give us 1 minus 2, 3, 9, 0, 1, 3, 5, 0, and then this will be 0. This will be 2 minus 1 plus 5 is 4. So this is the leading one, this is the leading one. So we expect this one also to be 1. And if we have 2 to get 1, simply divide by 2 or multiply by half. So therefore, row 1, the next step will be row 1, row 2, the next step remains to be row 2, and then row 3, we say a half of row 3, so that we can get this as 1. So that one leads to 1 minus 2, 3, 9, 0, 1, 3, 5, 0, 0, 1, a half of 4 is 2. So this is in the row echelon form, because this is 1, and then this is 1. So therefore, if we were to use, if you are doing Gaussian elimination, we stop here and then rewrite the system, and then use back substitution to solve. But for Gauss-Jordan elimination method, we are expected to also have this position 0, this position 0, this position 0. So therefore, the first step will take care of this part here. So we say row 1 will be given by row 1, and then plus twice row 2. And then row 2, let it to be row 2, and then row 3, let it be row 3 for this step. So that will give us 1, and then minus 2 plus 2 times 1, this is 0. 3 plus 2 times this one, 3 plus 2 times 3, that's 9. And then 9 plus 5 times 2 is 19. And then 0, 1, 3, 5, 0, 0, 1, and then 2. So that's what we have. So the remaining problem is to make 9, 0 to make 3, 0. And we do this one by, so say row 1, so that I get this to be 0, I'll say row 1 minus plus minus 9 times row 1, times row 3, not row 1. And then row 2, this will be 0, so I'll say row 2 plus minus 3, row 3, and then row 3 is just in the correct format, remains to be row 3. So row 3. So this leads us to, so 1 plus minus 9 times 0 is 1. 0 plus minus 9 times 0 is 0. 9 plus minus 9 times 1 is 0. 19 plus minus 9 times 2, that gives us 19 minus 18, which is 1. And then 0 plus minus 3 times 0 is 0. 1 plus minus 3 times 0 is 1. 3 plus minus 3 times 1 is 0. 5 plus minus 3 times 2 is 5 minus 6, which is minus 1. This is 0, this is 0, this is 1, and this is 2. So this matrix we have obtained. So you see this is 1, this is 1, this is 1, and all other positions are zeros. So this is in the reduced row echelon form. And therefore from this one, the next step, we say from this we have the system x1 equals to 1, x2 equals to -1, and x3 equals to 2. So therefore, the solution to our system is x1 equals to 1, x2 equals to -1, and x3 equals to 2. So that is how, how we are supposed to solve that problem. So thank you. And in the next video, we'll be demonstrating how to actually solve linear equations, system of linear equations, which has 4 unknowns using a Gauss-Jordan elimination method.